Well, welcome back. We're finishing up Part C of our MINITAB 6 assignment. So I have copied and pasted into my document the MINITAB results and commands that I use to do my hypothesis test. The commands are to sample. Of course, my data was in column C1 and C2. My testing, my null hypothesis value is 0, and the alternative, since it's a two-tailed test, is 0. And out popped my MINITAB output, and I found my test statistic, which is 0, which is 2.33, and the p-value, which is 0.025. Now I'm ready to do part 5, which says, do I reject or not reject? Well, since my p-value is less than my alpha, I'm going to reject the null hypothesis. So I start to write that, and then I change my A to alpha by going in here and changing that to symbol. Okay, so I've got my alpha now. And now I'm ready to state my answer in terms of the problem at a 0.05 significance level. There is, since I'm rejected, there is sufficient evidence. So you'd have at a 0.05 significance level, there is sufficient evidence to support the claim that the mean IQ of males differs from the mean IQ of females. Now, Part 7 deals with what if you knew that the IQ, let's say, what if we knew the IQ was different? Then you wouldn't have made a mistake. But what if you found out that the male and female males both had the same IQ? Well, then you've made a type 1 error. So those are the only two things that could happen in this because we rejected the null hypothesis. But if we didn't reject the null hypothesis and found out that the alternative was correct, that would have been a type 2 error. So that's what we're looking for in that last part, is for you to say, well, I rejected it when I shouldn't have. That's a type 1 error. Or, I rejected it, and I found out that it should have been rejected. Yay, I didn't do an error, that type of thing. Now, the second problem is also a two-sample problem with independent samples. So I'm not going to do one. I'm going to go right into the last problem, which is a proportion problem. So I'll get a made-up problem for us, and we're going to work that one out. So here's the problem. Problem 2. A simple random sample of 1,010 people who smoke. 848 of them said, yes, I believe that smoking will probably shorten my life. We want to do a 90% confidence interval, and then we want to do a sample size problem. What sample size is necessary to have a margin of error of 0.05 for this 90% confidence interval? And then we're going to do a test of significance. Has the percentage of smokers who believe that smoking will probably shorten their life, has it increased from 80%? So here we have the command. We use P-O-N-E, PONE, 1,010. That's our sample size. And how many agreed? 848. We want to do a 90% confidence interval, and we want to say UZ because we want to use the normal approximation. There's our answer. So we're going to copy and paste our commands and the output into our MINITAB. And so I'm going to paste the commands in and then write up my answer. And there we have one interpretation of it that we could use. Now we're going to do the sample size problem. So I'm going to use MINITAB. You could use your calculator. So I'm going to do the let command. So let K2, which is going to be my sample size, it's going to be 0.5 times 0.5, or you could have just done 0.25, times this quantity squared. Since we're doing a 90% confidence interval, that's 1.645 divided by the margin of error we wanted was 0.05, which is larger than the margin of error we just calculated, by the way. So our sample size should be smaller, and we need to square that. So we want to print K2, and there we have our sample size. It would be 271. Now, had I have gotten just 270, I would have used 270, but since I have something after the decimal place, we always go one more integer. We go to the next greatest integer. So our answer is 271 is our sample size. So the write-up in terms of the problem would be something like this. The sample size for the 90% confidence interval with a margin of error no greater than 5% is 271. Now we're ready to do the hypothesis test. So here we have our We want to test has the percentage of smokers who believe that smoking will probably shorten their life increased from 80%. So we write the null and alternative hypothesis is that our proportion is 80% versus that it's increased. That's increased from 80%. So now we can write, well, we have to have a significance level, so I'll make one up. Let's say 0.0, let's say 0.1. So there we write in the significance level. Now we're ready to do the find the test statistic and the p-value. So now we need our MINITAB. So here's the command. It's again p1 for proportion, one sample proportion. There's our sample size 1010. The number of successes 848. We want to test that 80%. The alternative is 1 because we think that it's greater. It's increased from 80%. So we use alternative 1. And the very last line is UZ because we're going to use the normal approximation for this. And now we just hit enter and we'll get our answer. And now we have to copy and paste that into our document and write the p-value and the test statistic. So there's how we would round it out. The p-value is less than our significance level, so we'd reject the null hypothesis. So in terms of the problem, we'd say at a 0.1 significance level, there's sufficient evidence to support the claim that smoking will probably shorten their life, that a smoker thought that has increased from 80%. And then there'll be that same type problem, hey, if the real proportion was this, did you make a mistake? So that wraps up the MINITAB. Hope this helps. And we'll see you on the next installment of some of our chapter work.